My name is Scott Cheek. I am a senior field service representative here at Alteros. I entered into the Aerostat industry in 2010, where I trained here in the United States on multiple platforms and then deployed in theater to Afghanistan, installing, troubleshooting, and maintaining systems in theater. I chose to come to Alteros at the beginning of this year, mainly because I was intrigued by the technology associated with autonomy of flight. This is unheard of technology, it's new, so anyone who has previous Aerostat technology is going to be intrigued, and once you actually see the system fly by itself and it's a 3-tether system, you're in wow. So it's pretty neat to watch. The traditional systems usually require more manpower and they require heavy equipment associated with the commissioning of the systems. So that makes things a little bit more complex as far as logistics and personnel requirements, and also the limitations that may be associated with those systems. So our site survey is where we would send one of our personnel to go meet with the customer at their site that they have intended or designated for our system. And it just gives us the opportunity to build a better relationship with our customer and also see what their needs are and make sure we meet or exceed their expectations prior to our arrival. Some of the older systems, heavy equipment require like a larger tram type system to help lift the system into place to where you can actually bolt it together. With our system, we don't have to do that at all. We use manual labor and through rigging systems on the ground that comes with the equipment itself. So our side equipment trailer will come with our parts associated with the platform for the commissioning phase of the platform. We'll stage that equipment on the port and starboard side of the platform, and then we will integrate rigging to lift those pieces into place, and then we'll bolt them and secure them securely. So prior to our system being deployed, we would do what we call a site survey and make predetermined locations where we want to set our equipment up. So we deploy with 2 trailers. One we refer to as a set trailer, which is called the set equipment trailer. The other one is our platform. So once those 2 trailers arrive on site, they will be delivered to their predetermined locations that we did during our site survey. And then once they are there, we'll set them up and we'll start deinstalling these trailers and start staging our equipment for integration for assembly. We quote about 2 hours for the set trailer and 6 hours for the platform itself, so a total of 8 hours for complete integration. The legacy type systems require usually a minimum of 7 personnel that have to be on site 24/7 to maintain the operations for that system. And you need 4 people on the ground for any kind of launch or recovery for the traditional legacy systems. With Alteros, we don't have to be on site at all. We can do this remotely by the push of a button or through a calendar schedule system. So you reduce the amount of personnel or any kind of situation where there might be personnel on the ground where there could be conflicts or safety procedures that need to be taken in consideration. So our ST Flex system is monitored through what we call the NOC. It's our Network Operations Center, and it is where our systems can be monitored in real time through a secure network. And so these operators are in the operations center to manage the day-to-day systems of flight 24 hours a day, 7 days a week. So they will sit there and monitor the system, mitigate any risk or faults, and they will help monitor the weather conditions just in case they need to keep the system moored for an extended period of time because certain weather conditions will be persistent throughout the region. And once that weather system passes, it can go back into an autopilot phase. All right, so we are here in Fremont, New Hampshire at our Alteros facility, and we have our ST Flex here currently set up for flight, and I'm going to walk you through our site that we have here. So to my left over here is our set equipment trailer, and we'll walk through how this system comes packaged and how we unload it. So these is our racking systems here that we have for our platform arms that will be installed on the ST Flex platform itself, and they are strapped into place along with our other containers that hold our tools, our envelope, and other products that's required for assembly. Our system also comes with what we call our customer interface cabinet. This is where if the customer has any networking systems they want to install with our system, they can do it in their cabinet here that's designated just for them. Over here we have our own network cabinet here. This holds our secure network systems in it along with our fiber and power systems. And so that's what connects the platform to the set trailer and then to our network operations center. We also have our ground weather station that is associated with the set. It's installed here. It's assembly here, and this also interfaces with our ground network station. And this is where our incoming power would come from. Preferably, we would prefer shore power, but if not, then we can use a generator system to install our 3-phase 480 volt 60 hertz power requirements for our system. And then once that shore power comes here, we then run another power cable that goes out to our platform. Here we are with the ST Flex where it's completely assembled, so we're going to walk through what it looks like or what the steps would be for assembly. So initially, when this system is delivered to the site, obviously the aerostat's not on there or inflated, and the boom will actually be retracted inside the platform, and it will be pinned and secured and braked in place for transportation. Once it gets to site, we will unsecure the platform from the shipping mode, and then we will start placing the arms and putting those in place and extending the boom and making sure everything's tightened up and secured nice and tight and ready for inflation. So initially we would install our 2 cabinets that are on top of the platform, and we will use rigging in place for that. Again, we don't have to use any heavy equipment for this installation or commissioning. Once the cabinets are upright and secured, we would then install our port and starboard side support arms. And that's just your little right angled arms there to the port and starboard side of the platform. Once they are installed, we also do the aft end. We'll extend the boom, which also extends our tether, and then we'll do our support arms there for our pad structure there. So on the starboard side of the platform here, we have our aft tether. This is what gives power and data to our payloads. We also have our front starboard side tether. We have on the front of our aerostat, we have our INS. That's where we get our locations for our lat and long. That can also be integrated with payloads. And then we have our port side front tether system here. And then we have our generator here, so this system does self-test. So in the event that we did have some kind of failure, we know that our generator will kick on and prevent us from having any kind of catastrophic failure. So this is where our team members would get on the platform using this ladder system here, and then they can easily assemble the payload area there. Our payload area would just unzip there, and then we can easily assess the payload there for any kind of maintenance that be required, or to put a new payload on or change payloads out. We also have a port there where we can have a camera or some kind of ISR payload stick out below the payload enclosure bay if needed. Yeah, so the ST Flex is definitely a remarkable system. There's a lot of work and a lot of technology behind this system that has made it so great. This is the future of aerostat systems. The autonomous system is a very stable flight. It is a secure flight, and I believe it's going to be the future of aerostat systems.